my name is Todd Leva, Senior Architect of the Watson Explorer Advanced Edition, and I will be your host today. I'm very excited to present and demo to you our latest release of another solution package for Watson Explorer. The particular solution package I'm going to demonstrate shows how the Centers for Disease Control could use the Watson Explorer Advanced Edition to analyze emergency room admittance logs. Through unique text mining techniques, I will show how CDC scientists are able to discover potential public health threats and take action before they become pandemic. This video is intended for business analysts, data scientists, and those who are responsible for analyzing large numbers of documents to discover emerging trends, patterns, and any relevant information that might otherwise be overlooked in the text. This video is also intended for those already familiar with the Advanced Edition and would like to learn new ways to leverage the text mining techniques offered by Watson Explorer. So let's get started. I'm sure most of you are already familiar with the CDC, the Centers for Disease Control and Prevention. You are probably most familiar with the work they do to determine the 3 strains that make up the flu vaccine each year. But they do more than protect the nation from the flu. They cover a broad range of health-related topics as shown here. Anything from alcohol use and birth defects to tuberculosis and other infectious diseases. The CDC gathers data and statistics in each of these areas to gain insight to the cause and effect, predictors, or other correlations that may help them protect the nation's health. The National Hospital Ambulatory Medical Care Survey is one such source of data that the CDC administers. The CDC collects random samples of hospital emergency room admittance logs that captures pertinent information about each visit. The data is used by the CDC as a kind of early warning system, or canary in the mines, if you will, to diligently detect the emergence of a potential health hazard. In our demonstration today, we are going to analyze approximately 100,000 emergency room visits over the last decade. The survey data contains both structured information, such as patient demographics or types of tests that were performed, as well as unstructured information, such as the free text description of the patient's injury or condition, or any other salient information that would help in the doctor's diagnosis. Of course, all patient identification information has been redacted for privacy concerns. So let's start the demonstration by switching over to the content miner of Watson Explorer and see what we can discover in these documents. In the CDC solution package, I have customized the content miner to utilize only those text analytic features of Watson Explorer most relevant to our task. There is the familiar search bar at the top and the faceted navigation panel on the left. The document results list for our current search state is shown on the right, and in the middle are tabs we can select, providing different views and exploration techniques through our data. We are currently positioned on the time series view. Here we can see that there are 99,244 log entries spread over 10 years, starting in 2005 through 2014 of last year. You can select discrete years to focus on like this, or a range of years like this. The content miner provides 2 additional temporal views, namely the trends and deviations view, that are not shown in this solution package, but help you discover trends and patterns in the text that evolve over time. We will come back to the time series chart after gaining some insight into the CDC data. In our faceted navigation panel, I have configured facets for most of the metadata fields associated with the emergency room admittance logs. Facets allow us to quickly drill down into specific areas of our data. For example, by expanding the patient characteristics facet and selecting age range, we see a list of the age range groupings along with the number or frequency of emergency room visits by each age group. The correlation value shown next to the frequency is a relevancy measure calculated by Watson Explorer. It is used throughout the content miner and is extremely useful in separating the signal from the noise in the data. We will look more closely at the use of this number later in the demo. It is important to note that the facets can also be populated by the text analytics provided in Watson Explorer or your own text analytics developed using the Studio. In these cases, the facet values are obtained from the text itself, not just the metadata fields. The concepts facet at the bottom is an example of a text analytic generated facet and will be demonstrated in just a moment during our concept discovery task. As a CDC scientist, it is our job to explore these emergency room admittance logs and look for any emerging health hazards. Today we are choosing to use the concepts view of the content miner as our discovery starting point. But before we do that, let me explain what concepts are as they relate to text mining. If we look at a sample document summary in the search results, most of the words encountered can be generalized to a higher level concept. For example, the word analgesics can be generalized as a medicine, and a medicine can further be generalized as a drug, and so on. These generalizations of a word are not to be confused with synonyms, which are different words that have the same meaning, but instead are grammatically known as hypernyms, a more generalized term of a word. Conversely, a more specific term for a word is known as its hyponym, so analgesic is a hyponym of medicine. With this hyponym to hypernym relationship between words, it is easy to see that words in text can start to intersect at higher level concepts, or their hypernyms. For example, the word narcotic, which also appears in the summary text, has drug as its hypernym. This means that both of the words analgesic and narcotic can be thought of as a drug. It's just that narcotic is a special kind of drug that is also addictive, while analgesic is also a painkiller but not necessarily addictive. So concepts built this way can form a hierarchy of concepts all the way from the most specific words found in the text to their more general hypernym words or concepts. With this approach as a design point and using the Content Analytics Studio, we then built a concepts dictionary. The concept dictionary provides a word's hypernym if one exists and subsequently annotates a document with all of the hypernyms that are found and their ancestors as well. So let's see how these concepts can be used in the text mining process. The Concepts tab consists of a concept viewport in the middle occupying most of the tab space. At the bottom is a slider that controls which portion of the concept hierarchy you're currently viewing. There are 16 levels to the concept hierarchy, 0 being the most general and 16 being the most specific. We are currently positioned on and viewing the concepts at level 8. Levels 9 and 10 have been preloaded for deeper exploration. This scale will change as we drill down and up the concept tree. To the left are two information circles. The top circle lists the tally of concepts currently being viewed. In this case, we are looking at 1,583 concepts at level 8 for the entire collection. The bottom circle gives us the highest relevancy score. It is currently set to 1 because there is no subset of data to compare to. So all of the concepts being displayed are on an equal footing for now. More on this later. To the right are two slider viewing controls. The first is a conventional zoom in and out slider. You can zoom out like this to see more concepts in the viewport. Eventually the concept labels become too small to read, but the overall topology of the concept graph can still be made out. The slider to the far right allows you to separate the noise from the signal mentioned earlier and view only what the system suggests as potentially relevant concepts. More on this later as well. Now, to start our exploration, we can pan around the graph looking for interesting concepts like this. But since we know that these are admittance logs from hospital emergency rooms, we'd like to filter out those visits that involve trauma, such as automobile accidents, and focus only on those that involve some kind of illness. So let's start by searching for the illness concept. And sure enough, the concept is found and positioned in the center of our viewport. Notice that it is automatically selected and its circle is highlighted in cyan. Selected concepts are listed across the top here, and at any time you can focus on just the concepts that you have selected by checking here. This helps reduce the clutter in the viewport. The plus symbol inside the concept circle indicates that there are more detailed concepts or hyponyms at the next level. So let's click on the plus sign and reveal those. Being the CDC, we are more interested in diseases, so let's expand the disease concept as well. Now we see quite a few different kinds of diseases, all of which are interesting, but the one that catches my eye is the communicable diseases, so let's expand it as well. Now the graph is becoming a bit crowded. We can click on a link, like so, to highlight those concepts that are connected from that link on down, or we can remove them from our selection list above like this, and then click Focus On for our updated list of selected concepts. Now, let's expand the contagion concept and see what we get. Here we seem to be getting the flu and diphtheria, which are fever-related, and what appears to be the chickenpox-related visits. These seem interesting but not uncommon. Let's collapse the contagion concept for now and take a look at the infectious diseases concept. Here we have what appear to be more serious diseases to consider: tuberculosis, meningitis, whooping cough, to name a few. By hovering over the concept, a pop-up will appear showing you the number of documents that contain this concept. Documents equates to emergency room visits for this solution package. Note that there are 7 occurrences of tuberculosis, 11 for meningitis, and 80 for whooping cough. These are all highly contagious and potentially fatal diseases, so let's focus just on infectious diseases by removing our other selected concepts and focusing on just it. As you can in other Content Miner views, you can also add the currently selected facet, in this case infectious diseases concept, to our query so that we can now narrow down to just those documents and see their occurrences in the documents themselves. What is important to note here is that the words infectious diseases do not actually occur in the text of the documents, but rather they're hyponyms that cause the concepts to be generated. This is the power in concept discovery. With just a few clicks, we were able to quickly drill through relevant concepts whose literal words do not actually appear in the documents, but are linked to more specific words that are contained within the concept being explored. Now, another important feature of concept discovery to understand is that because the concepts themselves are maintained as facets in Watson Explorer, they also benefit from the same intrinsic correlation analysis that is performed by the Advanced Edition on all other facets. This is evident by the color coding of the concept currently being displayed, which is infectious diseases. As you will recall, the system automatically color codes in the Content Miner those facet values with unusually high correlation scores. It is an attempt by the system to separate the noise from the signal and alert you to potentially significant values that might require further investigation. Let's see how this is applied again in concept discovery with another example. After clearing out my current query, expanding my concept levels to include one additional level, and checking the setting to automatically expand all concepts, we are ready to start a new discovery. This time I'm interested in all emergency room visits involving food poisonings, so I'll start a search for food poisoning. But my query type ahead indicates that in addition to the phrase food poisoning, there is also the term foodstuffs. So to be inclusive, I'm going to OR these terms together and then issue my search. And this is what we get. A couple of things have happened here worth explaining. Out of the 100,000 log entries, 2,973 matched our query involving food poisoning. And the search results list has those query terms highlighted in their document summaries. You will also notice that 189 concepts are currently being displayed with the aggregate level counts displayed in the circle. But notice how the relevancy information circle and the relevancy slider and the concept circles themselves have all come alive with a set of gradient colors ranging from yellow to orange to red. These are the same familiar color codings surfaced in other views of the Content Miner that alert you to potentially significant values that might require further investigation. In this case, these are concepts that occur more frequently when looking at food poisoning emergencies as compared to all other emergency room visits. The relevancy information circle shows the highest relevancy score encountered and the proportional number of concepts for each relevancy level, and there are 15 of those, with each level getting its own gradient color. The relevancy slider also shows this same proportionality, but as it relates to all of the concepts encountered for the current concept level range setting. So by looking at the slider, you can see that there are quite a few more potentially irrelevant concepts, the gray area, than potentially relevant color-coded ones. Also note that the system has automatically positioned the relevancy slider at the beginning of the relevant concepts. This way, the viewport has all of the irrelevant concepts removed for you, so that you can focus on what may be the most relevant concepts. Now, I say maybe because the low-scored concepts may still be significant to your exploration. Remember that the relevancy scores are based in part on how often the concept appears in the current subset of documents on food poisoning as compared to all the other documents in the collection, a kind of correlation analysis. So it is still possible to have what may be meaningful concept to you not be scored high just because it doesn't occur frequently enough in the subset of documents. It may be an outlier or a newly emerging concept. You can still examine these less relevant concepts by adjusting the slider into the gray area to include those concepts like this. Notice that the number of concepts being viewed has jumped to 1,223. Quite a lot to examine, but available to browse through if you need be. Now let's reposition our slider back to the beginning of the relevant concepts and see how relevant they might be. Now only the colored concepts are being viewed, with the lower scored concepts marked in yellow and with smaller circles, and the red largest circles being those concepts with the highest scores. So let's pan around looking at some of these concepts. I see a lot of concepts related to seafood, such as fish, oysters, and crustaceans, a common source of food poisoning if not properly cooked. So the correlation scores seem to be working in this case. I see a concept on sepsis, which is a form of bacterial blood poisoning which affects the whole body and can be fatal. So let's drill down into this concept by selecting it and then adding it to our current query to focus on just those documents. We are now looking at 9 emergency room visits involving sepsis, and of those documents, the system has surfaced 29 new and highly correlated concepts as indicated by their larger size and red color. I see concepts such as thrombosis, which is a blood clotting of the veins, and illnesses involving the lungs, such as pneumonia. On closer examination of the documents themselves, it is revealed that all of the patients were age 75 or older, and that their sepsis was due to susceptibility to infections at an older age. In this case, the patient was 90 years old and had her PIC removed a few days ago in the nursing home. So it appears that this set of sepsis-related illnesses is not a cause for alarm, but the process we just went through does illustrate how concept discovery can be a valuable tool in understanding large volumes of text without manually reading the documents. And in this case, we were able to quickly gain insight into the various kinds of threats that might be affecting the nation's food supply. So this completes our demo today. You can download the CDC solution package free for use with your Watson Explorer from the IBM Text Analytic Catalog. Using your favorite internet search engine, just search for IBM Text Analytic Catalog and you should find it on your first page of search results. And the home page should look like what you see here. From the search bar of the catalog, type CDC Solution Package and then hit Enter. You should then be taken to the catalog download page for the CDC Solution Packages shown here. Then press the download button to receive your copy of the solution package as demonstrated today. I want to thank you for giving me a chance to share with you our latest advances in text analytics and hope you have a great day.